Welcome to this explainer. Today, we're tackling a massive, familiar challenge in the tech world, machine learning and algorithmic bias. But instead of, wading through dense white papers or insanely complex computing models, we're actually going to look at how an elementary school e-learning curriculum elegantly deconstructs this whole problem. It's fascinating because sometimes the absolute best way to untangle complex engineering challenges is just to look at how we'd explain them to a third grader. It totally strips away the jargon and gets right to the mechanics of the issue. Okay, let's dive into this.
So think about this. If you have 5 friends and exactly 5 candies, what is a fair way to share them? This curriculum starts with a scenario literally every child understands. And the answer? It's obvious, right? One for everyone. Before we even touch on algorithms or massive data sets, this lesson brilliantly grounds itself in fundamental human intuition. It starts the conversation from a place of everyday common sense rather than complex code.
It defines fairness simply, treating everyone equally, making sure everyone gets exactly what they need, and ensuring no one is left out. Whether it's, taking turns on the playground swings or eventually allocating digital resources, it establishes fairness as a baseline human virtue. It's a concept we inherently feel right in our gut from a very young age.
But when we jump from the sandbox to the server room, the curriculum points out a really fundamental difference. Humans intuitively grasp fairness. Artificial intelligence, on the other hand, well, it simply executes instructions. A machine doesn't have a moral compass. It doesn't have a conscience. It literally just follows its rules, the algorithms, completely literally into the exact letter.
So the crucial point is how this curriculum explains bias to an 8-year-old. It completely strips away the malice. It explains that when an AI system favors certain groups, there's no evil robot behind the screen plotting against humanity. It's simply a technical flaw. It happens because the AI was accidentally given unfair rules or it was trained on limited, narrow information.
It sets up this brilliant direct cause and effect. Flawed input, like, say, bad code, poorly phrased algorithms, or just incomplete data, mathematically and inevitably leads to exclusionary, unfair, real-world output. The system is just processing the errors it was handed in the first place.
To really anchor this for the students, the curriculum introduces a super relatable case study, the online toy recommender. Imagine a brand new online toy shop where the creators build an AI helper specifically designed to suggest the perfect toys for browsing kids. On paper, it sounds like a fantastic, really helpful digital assistant.
Let's move to and see how this builds in practice. First, the AI is trained, but the developers mostly feed it data sets of toys that boys typically liked, things like toy cars and action figures. Next, a young girl named Mia visits the shop and searches the site. Because of its unbalanced training, the AI mostly just shows her those boy toys, completely ignoring the whole wide variety of other toys she might actually love to see.
The critical takeaway for the students here is that the AI didn't decide to exclude Mia. The dataset simply lacked variety. The computer only knew about the tiny, narrow slice of information it was initially given. Without a complete picture, the AI created an exclusionary outcome completely devoid of any malicious intent. It just didn't know any better.
Fixing the code, making AI fairer. Now, what's really interesting about this slide is how it frames the solution. If we can teach kids to share toys fairly, we can absolutely teach machines to be inclusive. The technical fix requires a proactive approach, using diverse data sets packed with varied information, actively writing inclusive rules, and maintaining strict human oversight. You literally can't just deploy the code and walk away. A human always has to be holding the magnifying glass, checking the output. And this brilliantly illustrates the crowning lesson of the curriculum. Humans are always responsible for how AI works. We can't just shrug our shoulders and blame the machine when things go sideways. The technology is only ever going to be as responsible, as fair, and as ethical as the people who are building and monitoring it. When you really boil it down to its essence, ensuring equity in our most advanced systems is exactly like ensuring kids share their toys fairly on the playground. It requires setting good ground rules right from the start, paying close attention to what's happening, and stepping in quickly to correct things when someone gets left out. This back-to-basics framing cuts right through the technical jargon and reminds us of our core engineering responsibilities. Which leaves us with a final provocative thought to take away from this explainer. If our algorithms simply reflect exactly what we teach them, if they are literally just a mirror of our own data, how are our ingrained human biases currently shaping the technology we build today? And more importantly, how can we step up and demand an AI future that isn't just technologically smart, but is fundamentally kind? Thank you so much for exploring this with me today. Keep questioning everything, and I'll catch you on the next explainer.